Okay, this is chapter 7.2 on multiplication of monomials by polynomials. We start at question 4 here. So if you have any questions you want to go over in review for the test, which is before Christmas break, make sure you just fast forward to those questions you struggle with. These ones aren't so bad. These are one way to represent a multiplication of a monomial by a polynomial. So here we have a length of 3x and a width of 2x and 4. So technically, if I was to write this algebraically, it's 3x multiply 2x plus 4 would be the area of the whole shape. But what we do with the area model is we break it down into monomial times monomial parts. In this case, this little rectangle right here, which would be 3x times 2x, would have an area of 6x squared, because 3 times 2 is 6 and x times x is x squared. So we can simplify that particular part to be 6x squared. And this particular part here would be the product of 3x and 4, or 4 times 3x would be 12x's. So what that means is each of these parts represents a part of the whole. So 6x squared plus an additional 12x is the same thing as 3x times 2x plus 4. So therefore our answer is this. Okay, there's our original statement. There's our simplification. In the second part, we have 3k times 4k. So if I wanted 3k times 4k, that would be 12k squared. And then 4k times 3.6 would be 14.4k. So therefore, the product would be 4k multiplied by 3k plus 3.6 is equal to 12k squared and 14.4k. I always find instead of reading it as plus, if you read it as and, it kind of makes more sense. And in the last question, we have k times 3.2k, which would be 3.2k squared, and 5.1 times k would be 5.1k. So therefore, we'd have k multiplied by 3.2k plus 5.1. I'm sorry, that's illegible. Equals 3.2k squared plus 5.1k. In the second question, we have another area model, same thing. So again, I'm just going to fill it in now. You understand the idea behind it. So 4y times 3y is going to be 12y squared, and 4y times 7 is going to be a 28y. So therefore, our solution would be 12y squared plus 28y. Here we would have 3.5f squared, and here we would have 7f. So again, our answer would be, what is f plus 2 times 3.5f? The answer is 3.5f squared plus an additional 7f. And finally, here we'd have 14k, and here we'd have 1.8k squared. Our next question says expand each expression using an area model. So this time we're not given the picture, but we can do it. So here I'm going to make my rectangle. My length is going to be 3.2r plus an additional 1, and my width will be simply the monomial, in this case 4r. Inside here we'd get 12.8r squared. It's the product of those two, the length and width. And here we'd get 4r, so therefore the answer is 12.8r squared and 4r when we expand it. And finally, this one B, our monomial is half an a. Now remember, half an a could also be written like this or like this. Having a coefficient of a half in front of it makes it easier for the next part when we multiply our coefficients. So this is going to be a 3a and this is going to be a 6. So here we're going to have the product of a half a times 3a. So a half times 3. Half times 3 can be thought of as being half of 3. And half of 3 is 1.5. So our coefficients when they get together are going to be 1.5. And a times a is going to be a squared. So the area of this particular part is going to be 1.5a squared. And here we're going to have a half a multiplied by 6, or a half multiplied by 6, which is half of 6, which is 3, and an a. So the area of that part will be 3a. So our answer for the solution for this one is going to be 1.5a squared and an additional 3a when we use this distributive property idea. Question number 7, again, area model. I'm going to skip it because we just did the last one. It's not too much different, and we're running out of time. Question number 8, we're starting to use a second method for determining the product of a monomial times a binomial. So this one, it's almost the same thing. So if I was drawing this using that area model that we just did, here's what it would look like. It would look like 3x here and 1 here, and it would look like 2x here, okay? So if we translated this picture for A into the last type of question, that's what it would look like. So this is an x, this is an x, and 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 this is a 1. So when we take this length and multiply it by this width, when we fill everything in, we see we have these are x squared tiles. We would have 6x squared tiles. So we'd have, hold on, let's just write this again. 2x multiplied by 3x plus 1 would equal 6x squared tiles, there they are right there, plus an additional 2x tiles. So there's our solution. There's what our picture on the outskirts was telling us, 2x times 3x plus 1, and our solution is 6x squared plus 2x. In the next question, our original question was, this is a negative x, this is a negative x, this is a negative 1, negative 1, negative 1. So it was a negative x plus, or negative x minus 3 as our polynomial, multiplied by our monomial, which was a negative x. So that's really what the outskirts tell us. And when we multiply those two, we see that we get a positive x squared, because a negative times a negative is a positive x squared. And we get 3x's, which we would have gotten a negative times a negative times a negative gives us a positive answer. And our third question, C, looks complicated, but it's not that bad. Here is our monomial right here. That's 3x's multiplied by a negative x plus 2. So if I was to write that using distributive property, it'd be 3x multiplied by a negative x plus 2. And inside will be our solution. That's going to be negative 3x squareds and 6x's. And again, we would have seen that had we expanded it using distributive property, we could have gotten the same answer. Question 9, same thing. So our monomial was negative 3x, which is represented here as our length of our rectangle, if you want to think of it, multiplied by a positive 2x plus 2, which is up here. And when we multiply those together, we get negative 6x squareds minus an additional 6x's as our solution. And B and C, yada, yada, they're all pretty well the same. We're going to skip them because we're running out of time. Question number 10 says expand each expression using algebra tiles. Now in this particular case, we want to draw our model. So I said before, it's easiest to have graph paper because it makes it nice and simple. Our monomial is 3x. I'm going to put that down here, so 3x's. Make sure you shade them in to indicate that they're positive. And over here we're going to put an x, which is positive, and a minus 5. So minus 1, minus 2, minus 3, minus 4, minus 5. Again, we want its width to be 1 and 1. Bring it down here, connect all the dots. This is a positive right here, and this is a positive, so these are going to be positives in here. This is a positive, this is a negative, so all of those ones inside are going to be negative, because a positive times positive x times a negative 1 is going to be a negative 1x. So when I interpret my solution, I'm going to have a terribly drawn 3x squareds minus 15x's as a solution. Okay, and B, when we draw our question, here's our monomial of 2x here, and our binomial of negative 2x plus 3 is up here. So we're going to connect all the dots here. Hopefully my squares are a little bit better than they were in the last one. No, not much better. And we have, these are going to be positives. Positive x's all the way up there. This is a negative and this is a positive, so we're going to have negatives in the middle. So our solution to this will be negative 4x squareds plus an additional 6x's as our solution. And we would have gotten the same answer. Again, this would have been achieved if we just used distributive property. Okay, question 12. Now we get into the nitty-gritty, the easy part, just expanding using distributive property. So again, just like you learned in grade 8 when we introduced distributive property with something simple, 2x has to be multiplied. The monomial has to be multiplied by each part of the polynomial in brackets. For the first 5 of them, they're just binomials. And question F has actually a trinomial, which is the same idea. So when I break this up, it's really 2x times 3x and 2x multiplied by negative 1. So 2x times 3x is the same thing as 2 times x times 3 times x, or simply a 2 times a 3 times an x, because it doesn't matter which order we multiply them in, which will give me 6x squared for that first term, and this will give me negative 2x. So when I take those and put them together, the solution will be 6x squared minus 2x. In your second question, 3p times 2p minus 0, 2p. 2p, you're going to get 6p squared minus 2.4p. Okay, again, you're multiplying the 3 by the 2 to get 6, the p by the p to get p squared, so 6p squared. The 3 by the negative 0.8 to get negative 2.4, and the p by nothing else to get negative p. In C, you have negative 0.5 m times 7 and negative 0.5 times 12. So if you want to rewrite it, it's this and it's this. And again, notice how the negative sign actually stayed with the 12. That's important that you do that. So 0.5 times 7 is 3.5 m, and this is going to be negative 0.6 m squared. So when I put them together, I get 3.5 m minus 0.6 m squared. Or if you reorder them in descending degree of terms, you could restructure that to be a negative 0.6 m squared plus 3.5 m. Now both answers are the same. I mean, this one here just technically is a little bit better because you did reorder it in descending degree of terms, so that's probably what you should do. That's the final solution, kind of like reducing a fraction to lowest terms. You just reorder your terms at the end. Question number D. We have 0. So again, here we have a binomial as your first term and a monomial as your second. What I always like to do is rewrite it so my monomial is first and my binomial is second. I just do it because that's the way my brain works. I even put my arrows in still. So a negative r times a half r. This here, well, a negative r is a negative 1 times a half will be a negative a half, and r times r is going to be r squared. So that first part is going to end up being a negative a half r squared. And the second part, negative r times negative 2, is going to be a positive 2r. So that will be the solution to D. Moving right along, E we're going to skip. We're going to go right on to F. So for question F, we have a trinomial this time multiplied by a binomial. The only difference is every term of the trinomial must be multiplied by 3x. The first one, 3x times x, will be 3x squared. 3x times 2y. Now watch, 3x multiplied by 2y is 3 times 2 times x times y, which would be 6. Now since x times y can't simplify beyond x times y, it's going to be staying as that term. So our next one is going to be plus 6xy. Thank you, Brock. Finally, the last term will be 3x times 4, which will simply be plus 12x. Now again, when we get into the next chapter where we have to gather like terms, you know that trinomial cannot be simplified because x squareds, xy's, and x's are not like terms, so that's as simplified as we can get for that. Question 14, some people struggled, some people didn't. It says a rectangular cubical button blanket has a width of 3x and a length of 4x minus 3. What is an expanded expression for the area of the blanket? Well, since it's a rectangle, our area is length times width. We'll treat the monomial as the length, since I always want to do a monomial multiplied by a binomial. And when I expand it, the expanded expression for the area will be 12x squared minus 9x. That's the answer for A. Now for B, again, we're getting into this chapter 5 question again. We're going to add all the sides together. So the perimeter will be this length plus this width plus this length plus this width. And now we can gather like terms because we're adding a binomial to a monomial. How many x's in total would I have? I'd have 14 x's minus 6 being the perimeter of that particular blanket. And finally, finally, we got enough time for, I think, for two more. Lee has decided to build his shed on a square slab. So this is the width and this is the width. This is a square slab of concrete. But the shed that rests right here is 2 meters shorter. So if I was to define the width, the length of the shed would be W, but the width of the shed is 2 meters shorter, so it's going to be 2 meters shorter than the width. What is an expression for the area of the shed? Well, the area of the shed, again, will be W, this is A, multiplied by W minus 2. When I expand it, I will have W squared minus 2W for the area. So therefore, the area of the shed will be W squared minus 2W. And it says, if the width of the slab is 4, what is the actual area of the shed? So here we're just going to substitute 4 for W. 4 squared will be 16, minus 2 times 4, which is 8. The actual area of the shed would be 8 square meters when I substitute 4 for W. Question 8, the basketball court for Jeux de Francophonie is 5.5 longer than 1.5 times its width. So here's the basketball court. So when I put down W for my width, it says the length of the court is 5.5 meters longer than 1.5 times its width. So 1.5 times its width plus an additional 5.5 meters is what the length of this court is. So what's an expression for the area? It would again be the monomial times the length, which in this case is 1.5 W plus 5.5. Expand it using distributive property. The area will be 1.5 W squared plus 5.5 W. And again, if the length is 28, what is the width? So here we got a little bit more. If this length here is 28, I have to figure out the width by doing this. The length is equal to 28. Now I have a two-step algebraic equation. Subtract the 5.5 from both sides. 1.5 W equals 22.5. Divide both sides by the coefficient. And W will equal, 22.5 divided by 1.5. The width is 15. Okay, I think that's all the time we have. Unfortunately, we won't get to the last question, but good news for you, it's not on your test.